Okay, so I'm gonna get ready to share my screen now. So it's a pleasure to be able to share this research with you all after having been working on this project for, it's over a year now. So as you can see on the title, I'm going to be talking about a paper that has recently been accepted in the journal Cognitive Behavioral Neurology that I worked on with two of my colleagues. I'll just mention Ken Richman was a fellow philosophy major with me at Haverford College. And Elizabeth Kensinger, most of you know, is an experimental psychologist and the chair of the Department of Psychology and Neuroscience at Boston College. And I wanted to begin by having a little discussion and of this question here, which is, why did consciousness develop? What does it do, and what is it good for? And as many people know, I really like to get everybody involved in discussions if possible and if they want to. So I would love to hear from as many different people on this, and I have about like 8 other questions. So I'd love to hear people's thoughts, and if everyone can give their thoughts, and then continue to hear from other people if you have other thoughts on this topic. And let's just make it informal. So as far as I'm concerned, you can just shout out and start talking, or you can unmute yourself, and that's sort of a sign that you're gonna jump in.
So I'll jump in. I liked the explanation you gave in your paper, that it's sort of used as a way to sort of plan ahead future actions at times that are convenient. And I think it's interesting to think of that in like situations where, say you're like in fight or flight mode, you're very much in the moment, you're probably not, your mind's not wandering. But those times you're doing routine actions and you can kind of like take a moment to be safe is sort of how I thought of it coming. You can sort of plan out your next course of action to stay safe. So like environmentally, that's sort of my thought on how it developed and why.
Yeah, no, great. Other thoughts? What consciousness is good for?
I guess if I hadn't read your paper, I might have tried to say that it's a useful way of processing stimuli in the environment and sort of unifying it together and into one sort of observer. And there might be, advantages in terms of survival, in terms of genes and sort of other reasons. But I think maybe it's just a way of selectively sort of choosing out of all the stimuli we're presented with, sort of which we're going to take in and identify with, and sort of, I don't know how to put it into words, but yeah. That's sort of what I'm trying to communicate.
Yeah, so to help choose which of all the different things to pay attention to in the environment or in terms of our own internal urges, which one should we pay attention to, should we focus on?
Yeah.
Yeah, no, I love that. Other thoughts?
Maybe building off that, I was thinking also that consciousness is really the link between our past experience, what we learn from them, and then how we approach future things that come up in life. So it's really just, it's what builds personal growth, and like both at evolutionary level, but also just in terms of every individual, like how they consciously build up from their previous experiences.
That's very interesting that you associate that with consciousness. Is that because I've already brainwashed you into thinking consciousness is the same as memory, or are you thinking of consciousness are you thinking of it like sort of like personality, or?
Yes, maybe because I think of, I don't know, because in English for me, consciousness is a really hard, I don't know. I think more from the Italian translation, which is, it then leads to a term that links back to more like personality, like persona, individual. So that's how I link it.
What's the Italian word again?
So it's coscienza, which is very similar to this, but coscienza is always, even in books and literature, is always the mind in your brain. Like it's the image of someone in your brain that tells you what to do and how to behave.
Like the little homunculus.
Yes, yeah. So that's how I brought it. But
other thoughts?
I find it helpful to sometimes like try to think of synonyms. And so like I was sort of, as Kate was speaking, I was thinking about alertness and that sort of like selectivity component. But then even just from my own background, what I would bring in is maybe like that general sort of awareness. So things can be represented at, what you would call an object level. So like their sort of reality of it. And then there's this meta level, which is our conceptualization of it. So we think of metacognition as our thinking of our own thinking. And so I think that consciousness encapsulates this, awareness of things that are sort of real and tangible, or sort of that, are a basic process like memory, but then also this meta memory, our sort of thinking about our own thinking too, I think is also something that I would associate with this.
Yeah, and you may or may not know, Renee, there's a higher order theory of consciousness. Are you familiar with that school?
I'm not.
Yeah, so you have just articulated what they think of as consciousness. So they would say, and I would say, I don't know that I would, well, I sort of talk about it a little bit. But if you see something that's red and you're simply perceiving red, they would argue that's not necessarily, that you're not necessarily conscious of it. It's only when you're thinking about the fact that you're looking at a red object and its redness, then you're conscious of it. That's sort of higher order theory of consciousness. Yeah.
Makes sense.
Well, let's talk about the next question here. And I'd love if people haven't yet had an opportunity to chime in. Maybe the last question didn't pull you. Maybe you'd be interested in this or one of the other ones. So why is consciousness so difficult to control? And if you don't know what I mean, if you've ever tried to practice mindfulness or perhaps other types of meditations, I confess, I really just know about mindfulness. And even I would say the mindfulness that I practice, which is trying to focus on my breath or sometimes sensory experiences in the environment, and try to, if I find my mind wandering and sort of daydreaming, I try to bring it back. And Kate and I have talked about that. That's certainly not the only goal of mindfulness, but that's sort of the goal that I try. And I find it difficult to keep the contents of my consciousness on the object that I'm trying to. So I don't know if others have experienced it, but I'm interested in other people's introspection and their experience. And if you, like I do, find that it's difficult, what your thoughts are as to why it's difficult.
I would agree that it can be difficult, but I think, at least for me, it's usually external, or like the environment that I'm in that's kind of made it hard or difficult to control. If that's either like outside, because I live in the city, so you hear the bus and all that stuff. So it makes it difficult to just focus on one thing. So what's helped for me is have a certain time, or before I wake up in the morning is when I take my time, because it's usually quiet. No one's awake. And it's giving me the time to like control, and it's been consistent, of more of a routine. So that's how I've been able to control it, I feel. But I do agree that in general, it's difficult to control and hard.
Oh, that's really cool. So you're like, you wake up, you're lying in bed and you just do it right then before you get out of bed?
No, I get out of bed and I go into a different space.
Oh.
And I just sit there for a while and just like either like I pray. So I usually pray or I just read something. And that's kind of like centered me and like get ready for the day kind of thing. So that's how I've learned to control it. Because if I stayed in bed, then I'm gonna go on my phone. So that's just not gonna work.
Interesting. Yeah, yeah, cool. Other thoughts?
I just keep thinking of attention. And like one thought I just had when Samrana was talking is that like, it almost seems that in a busy city, it might be the easiest place to stay mindful because your attention is constantly being pulled. So you'd be attending to the environment and being in the moment, which is kind of how I think of mindfulness. If you're safe and comfortable in like a quiet environment, that's the best time for your mind to wander because there's no threat. You're safe and stuff, but it's sort of like a muscle that you have to flex, I guess, and get better at with practice. I think it's like almost involuntary, which is why it's so hard to control.
Other thoughts?
I'd love to jump in. I think if I was looking at consciousness in sort of an evolutionary sense, I think that there's a lot that you have to fight that's supposed to be protecting you for survival, kind of going into what Kylie said. So there's that need and want to be attentive to your surroundings. So I think that that's why mindfulness can be so difficult, but maybe why a meditation such as walking meditation can be a little bit more natural for someone because you're focusing on a task at the same time, which just allows like the mind to slow and you can focus on being in the moment and being present with your surroundings. Or at least that's how I am able to try to be mindful. So.
Great.
Can I provide one counterpoint about mindfulness? We talked about it before, Andrew, but I feel like as I've gotten more into mindfulness, my goal in mindfulness has changed from wanting to focus on breath and sort of saying that's a successful session if I focused on my breath the whole time. And now I see it as a successful session if my mind wanders, if I realize it and I'm able to bring my mind back. So that practice of continually doing it, continually realizing the mind has sort of gotten on a new train or gone in a new direction and then bringing it back is I think the point of practice. So the mind will wander. That's not a failure of the practice. And what you're training is that metacognition that Renee was talking about. So just having an additional observer that's watching what the mind is doing, the mind can do what it wants. But as long as you're able to observe it, you've been successful. So I guess I kind of want to rephrase this like hard thing. I think I don't think any of us is failing when we notice the mind is wandering is all.
Are we failing when we don't notice the mind is wandering?
I think a meditation expert would probably say no, there's no failure or success in mindfulness. There are a lot of the sort of like phrases and the ways we conceptualize success and failure in the workplace and other areas sort of don't apply in mindfulness. So honestly, I'd love to have like a mindfulness practitioner or someone else come on and talk about it at some point. But I don't think that they would say that that's failing either.
Yeah. Great. Other thoughts? Yeah, I certainly don't consider myself an expert in mindfulness. What about this one? Anyone like to weigh in on this question? Are your actions under your conscious control? If so, how come, dieting, resisting other urges are hard or difficult, at least for some people? I'm not saying for everyone. Anybody have any thoughts on this?
I what comes to mind for me, at least with the dieting example, is that you consciously know that you should stop yourself, but on a, you know, on a more basic level, you can still eat, you can still reach for the food, you can still do it. So you yourself know that you can do it and you have that option. And then it's your little voice, your consciousness, then that it's harder to control. But you know that you can, you're not incapable of doing something. So it's like the opposite. And it's so much harder, right, to do something that you know it's hard to do and work for it. Like you have to put your consciousness into that. But when it's stepping back, that it's harder. Where's your, yeah. And that's hard with dieting, for example, but with anything else as well.
I want to just piggyback on what Anna's saying. I think this situation perhaps highlights that there are systems in conflict within the mind and within the brain, and it brings up the question of who is in charge, what is controlling. Is dieting really your goal if you're not dieting? So, I mean, we can argue about free will, which is a separate, very interesting, deep discussion. But I think there is this conflict. I think anyone who has tried to do anything that they don't particularly, are inclined to do is that they find this conflict between systems.
To piggyback off of that, I also think that sometimes it also depends on which system is running the show. So sometimes it's system one, which I think is like the quick, intuitive one, or system two, which is like slow, deliberative. I might make a long-term decision using the system, whereas if I eat a cookie or not is probably just going to be my quick. I'm not going to put much thought into it.
Kylie, which one is you?
Oh my God, both? They interact?
It's tough, right?
I think that's where the mind-body problem starts coming into play more, because you sort of see that play there. Is it? Yeah.
I mean, but there are assumptions coming into it that we are one unitary individual, and not just a collection or group of systems all vying for, for supremacy, perhaps, or collaboration if you're charitable.
Yeah, these are the instances where the dualists, I'm like, you might have had a point there. I know they're connected, but.
Other thoughts?
I've sort of come around to the idea that a lot of the time we're just operating by instinct. And we're not, and this is sort of what you said in the paper, that most of the time, unless we're really working on to be mindful or be present in the moment, or there's something activating a higher level of awareness, we are probably just acting sort of as automatons and just sort of going through the motions, acting by instinct, eating what we want, behaving how we want, which is a little scary.
I'm so happy that you started. Well, I mean, yeah, a little scary, but like I was just about to say like something where I think about like dieting specifically, I just think about like behaviorism brains. Like I think that it's so difficult because there are all these environmental cues that we've been taught through various associations. And so I think that like really, I don't know, should consciousness even be implicated in something like this, that type of like behavioral restriction, when you can maybe just apply like a behaviorist lens to it and think about different types of reinforcement in the environments and things. I don't know.
Yeah, no, I love all these comments. I think they're all right on target. How about this one? Who'd like to weigh in on this one? I'd love to hear from someone we haven't heard from if they're interested in chiming in on this one. Has anyone had the experience of?
Yeah.
Yeah.
I was initially going to say no, of course not. But then I remembered, I do have those times where you go from point A to point B and you're driving and you just kind of wasn't there you weren't there for like 5 minutes or so, because I don't know why that happens, but I've definitely had that experience. Like my mind is elsewhere, even though I'm being safe and driving safely, I'm just not really there.
Absolutely. Yeah, no, I've had the same experience. And you wonder, like, how did I get here? Like, I don't remember the last 5 minutes, even though I was driving. Anybody else do another complicated type of activity and they realize that they do it without really being conscious of it? How about this one? Are animals conscious? And I guess humans, of course, are animals. So I mean, any non-human animals? If so, which ones and how do you know? Several of you have pets. I'd be very curious to hear whether you think your pets are conscious or whether they're not.
I would say yes. I don't have a pet, but I've dogs sit for people before, and I think they're just really or can be really aware of their environment and conscious of like the people that they're around and the environment as well. So yeah, I would say yes.
Yeah. And I love how you explain that, Raisha, because basically what I think I heard you say is you think they're conscious because they behave like they're conscious.
Right. Yeah,
Yeah.
and they can pick up on like how people in the room are behaving. And so it's not like things are happening without them being conscious of it. They are aware. So yeah.
I love that answer because many philosophers have argued that that's the only way we know that anybody else is conscious, is by observing their behavior and saying, well, they behave as if they're conscious, so I assume they're conscious. I'm totally with you.
Mhm.
Any other thoughts? Anybody want to weigh in on their animals? A couple of you have cats. Are cats conscious? Or maybe some specific cats, but not other cats?
I think they might be more conscious than we are, if anything. They're in control.
They're metaconscious?
I think that this is a very interesting question because I listened to a podcast once that was talking about whether or not animals have emotion and like complex emotion, and I think that those questions really can meld together because maybe animals are conscious, but maybe that also can be that they don't truly experience the same emotions and we're just perceiving them as having an emotional response, but it's actually just their behavior. I don't know, it can get very muddled.
There's a researcher at BC, I believe, that actually does MRIs on dogs. And I think that's a large part of his work, is just seeing if dogs experience emotion similarly to how we do.
Mm-hmm.
Well, I like what you said, Brenna, because to some extent, it was almost the opposite view of Raisha. Raisha is saying, well, I dog sit and dogs act as if they're conscious, so I think they're conscious. And you're saying, well, but maybe it's behavior that's not necessarily related to consciousness. And I think that's a totally legitimate point as well.
Yeah, specifically looking at like the guilty dog thing. Everyone knows about the guilty dog, but is the dog actually guilty, or are they just expressing a behavior that you are perceiving as guilty because we have a word to describe the emotion of guilt? It's maybe not as complex in their perspective. They just know that if they elicit this specific behavior, that we're going to perceive it as guilt. So the same thing is like with their consciousness. Maybe it's not. I don't know.
I can speak about a very weird experience for my cat, where I believe that she's conscious because last summer she just went on the roof and fell into the chimney, and there was so it was a very traumatic experience. We had to call the firemen. There was a whole nightmare of a night, but well, she's not going outside anymore. She's not interested about the outside. And I think in a way, well, it could be just, reinforcement, like very negative reinforcement. She's not going outside anymore. But I do think that just learning from that experience, no matter if it's just reinforcement or if there is emotion involved, I think it's already being conscious. Like it already means that she has a consciousness, because otherwise the behavior would continue if it's an instinct that wants to and it's an animal, so she would want to go outside, so it's her instinct. But I think she really learned from that experience.
So Anna, I want to push you on what you just said a little bit. So on the one hand, I don't necessarily disagree with anything that you said, but as my PhD student, I want to make sure that you consider the alternatives. So I would say that I totally agree with your statement that she learned from the experience and she changed her behavior after that experience. But, are there other mechanisms that would allow her to learn from an experience that would change her behavior other than a conscious, explicit memory?
There definitely are.
Such as?
So I think it's hard for me to think when I think about an action in general, maybe because it's my animal, but I always think that it's if there's control, there's consciousness. Like that's how I link it together. I might be now missing your point, but
no, I think not at all. So some of the implicit memory systems.
Yeah, so it would be like procedural memory, or I would call it here like procedural.
Or priming, or conditioning. And with conditioning, there's sort of classical conditioning, which involves a physiologic response. There's operant conditioning, where you can have the pairing of two stimuli that don't necessarily have to invoke a direct physiological response. There's motor conditioning. There's a lot of different kinds of conditioning. So I think that your cat may have simply learned through conditioning, and I'm sort of playing devil's advocate, right? Your cat may have learned through conditioning that I go outside and then I fall down the chimney. This is a painful, unpleasant experience, so therefore I'm not going to go outside anymore. So your cat may have been conscious, and it may have been a conscious learning and conscious decision, but I would argue that it's at least possible that it could have been through conditioning.
Is another way you could think about it as almost like a spectrum of consciousness, and you kind of touch on this in your paper when you talk about basically the number of neurons an animal has. But that's sort of what I started thinking of it as, almost like a cat's vision. If you thought of it as vision, almost consciousness, it might be a little blurred compared to, say, a human's, because we have higher level structures in our brain that are developed that can kind of consciously attend to different parts of the environment at once and stuff. But so maybe you could definitely probably argue that animals are less conscious than humans, but I don't think it's fair to say that anything is unconscious.
Anything?
Not anything.
Anything?
Mammals, you sold me on.
Right. I mean, do we agree rocks? They're not conscious.
Not conscious, but I think just the neuron, once you start building life, that's when you start getting into consciousness. And that's where that question, is an amoeba consciousness? I would probably say no. But I don't know. I'm thinking of it more as a spectrum rather than just conscious versus not conscious.
No, I'm totally with you. And as you know, in the paper, I ended up concluding that I thought there was evidence that vertebrates were conscious. But I guess I would say I don't know about invertebrates, although certainly octopuses are felt to be one of the more intelligent species, and they're not vertebrates. So I'm not saying that invertebrates are not conscious. I'm just simply saying I think there's evidence that vertebrates are conscious. So interesting idea. Let's touch on this one. What do people think? Are there developmental, neurologic, or psychiatric disorders that are disorders of consciousness? And I think it's fine. You can bring up some of the things I mentioned in the paper if you read it, or just things you think of in your own mind, or you can say, absolutely not, that you don't think there are any. What do people think? Is this one of these questions? Is it too hard or too easy?
Me again. I think it's just very interesting. Like I'm thinking of schizophrenia and just how their perceptual experience sort of gives them a completely different experience of consciousness. They are experiencing things that aren't there. Which is just I don't know. So it's hard. There's a lot to think about here and unpack.
Oh, I agree. I mean, as you know, I would argue that I think I agree. I think schizophrenia is a disorder of consciousness. The root of the word, as you may know, is like it's like divided mind, and I agree. Anybody else want to either bring up something I brought up in the paper, or maybe disagree, that maybe think I've gone too far, which is certainly possible?
Well, this is more debatable, but I was thinking of dissociative identity disorder very immediately, because I remember learning about a theory about a way that a patient would describe it is as if you're in a car and sometimes they feel like the driver, or sometimes they can feel like the passenger, and it can be this really disorienting change of their consciousness. There's a lot more room of speculation there, but I thought of that pretty immediately.
No, I totally agree. It's one of the examples used as well. I would agree with you. I think that's a disorder of consciousness, especially because as you will see, and as the title slide proclaimed, I think consciousness and memory are intertwined. And one of the things I think is so interesting about dissociative identity disorder is that some identities have different memories than some of the other identities. Not always, but often. It's one of the more interesting things about it. Any other thoughts about disorders of consciousness?
I guess having done neurology residency, I think there are just so many neurologic disorders that have disorders of consciousness as part of them. Almost too many to give examples of, but one that some people might have clinical experience with is just this waxing and waning in the level of consciousness that comes along with dementia with Lewy bodies might be a good example. But there could be many other examples to talk about. There can be strokes that involve centers in the brainstem or cortex that affect the level of consciousness, severe traumatic brain injury, just many other examples. So
yeah, no, I love that. And that actually goes right into sort of how do we define consciousness. And do you want to just expand briefly, Kate, on like sort of levels of consciousness? I know obviously the clinicians here know what that is, but I'm not sure everyone does.
Oh, yeah, there's a rating system for the levels of consciousness, and I actually don't have it memorized.
Oh, and I don't either. I just meant a description, not a.
Yeah, so clinicians, when someone comes in, with a decreased level of consciousness, we sort of rate it on this scale, and it's widely accepted, and we can sort of talk back and forth about sort of how severe someone's traumatic brain injury is or stroke based on this scale. And yeah, I actually can't remember what you think of the scale, Andrew, in terms of how accurate it is and how useful it is.
Yeah, I mean, I know people talk about the Glasgow Coma Scale a lot. I mean, I still remember, the way that I would sort of write my note is that somebody's in coma, or they're, stuporous and sort of minimally, aroused, or they're delirious, or and then they're like drowsy or confused, sort of just go up in different sort of levels. Other thoughts about what people mean by consciousness. So we've just described sort of levels of consciousness. That's sort of one way to think about a consciousness definition. So I'll just jump in here. I'll read Indra, who's having trouble. Oh, right, she's in the library. But she was saying that in her psychiatry module, that she was thinking about deep personalization, derealization, and somatic symptoms disorder, and the state of delirium as all disorders of consciousness, which I would certainly agree of, and I think we talked about all of those or most of those in the paper. Totally agree. So let's talk a little bit about some of the basic properties of consciousness. So this is from Dan Schachter and colleagues' introductory textbook on psychology. So there's intentionality that consciousness is directed toward an object, right? It's about something. It's, as we talked about here, that it's provides a unified experience. So we don't experience separate sights, sounds, smells, thoughts, feelings. We experience these things as a coherent whole, bound together. Selectivity, we also talked about, that we're conscious of some things and not other things. We talked about this in the context of what we might want to be thinking about evolutionarily. And there's transience. The idea is that objects of consciousness aren't there all the time. They sort of come and they go, whether it's related to mindfulness or just ordinary daily activity. The contents of consciousness tend to change. Then the next thing I have here is another question, which is, why does consciousness feel, in the words of William James, like a stream? It's attributed to James that we have this sort of stream of consciousness metaphor, that he was the first to coin that term. What does that mean to people? And do you agree with it?
For me, it just sort of means that it's never off. Like you're always, there's always that little chatter in the back of your head.
Yeah.
And I'm someone that spends a lot of time like stuck in my own head. I have trouble like being in the moment very much. And I feel like for some people, it's like a river almost, like it's so hard to control where your mind goes sometimes, but I think it's a great metaphor.
Yeah. Yeah, it resonates with a lot of people. You can think there's sort of a now where things are sort of swirling around your feet in the present. You can sort of look downstream, things that have flowed down the river, that are in the past. And you can look upstream too, of things, that are about to happen, right? Now, what's interesting is a river is linear. more or less. I guess it's not two-dimensional, it's three-dimensional, but it's pretty linear. But we know the brain is just processing massive amounts of information in parallel. And, so the question comes up, well, but do we really, does consciousness flow in this sort of linear manner like time? And now I'm going to start to talk about the things that have been sort of problematic about consciousness, which is that consciousness often occurs after the perception. And if we're conscious of something after the perception, the question is like, well, were we conscious of it at the time or not? And I have this clock here because a quote that's actually turns out when I went to the original Principles of Psychology by William James, which in fact, I should mention to people, I read it at a suggestion from Elizabeth Kensinger. And I've known about this book, for 20 years. I'd never read it. It's wonderful. It's long. And some parts are out of date, but it's really a fun, believe it or not, it's a fun book to read if you're interested. So people often say James said this, but he actually translated it from Exner, who wrote it in German. And the idea is that sometimes when you're absorbed in something, you can hear the clock strike, the bells toll, but not pay attention to it. But then after, the final reverberation is dying away, you can then count off the strokes of the clock, somehow allowing you to be conscious of it in the past. And this comes into this cocktail party effect, which is perhaps something that's a little bit more relatable to people, where it's very interesting that you can be talking in a group of people and you'll hear your name. And not only will you hear your name, but you will be able to infer or remember what was said before your name, leading up to it. And again, the question is, well, were you listening and aware of it or not? And this is just a few examples that feed into this whole idea of postdictive events. And the idea of a predictive effect is something that happens before that affects something later, right? Which makes perfect sense. But a postdictive effect is that something that happens later can affect something that happens earlier. So that's a little bit, at least for me, very counterintuitive, right? So it's that a later stimulus can affect the perception of an earlier stimulus, or earlier and later stimuli can mutually affect each other. And this is perhaps not quite as, at least, uncommon as you might think. We all know about backward masking. And, well, if you don't, I'll tell you right now. So if you showed this face alone, even for 50 milliseconds, whatever the time is, you showed it alone, you would be able to see that face. You'd be able to perceive it, even if it was only flashed up for 50 seconds. But if you flash this face up for 50 seconds, followed by this 50-second backwards mask, then you cannot consciously see the face. So masking is an example. Backwards masking is an example of a postdictive effects. Now, some people might say, yeah, but that's just perception. That's not consciousness, but nonetheless, it's an effect that occurs. We have a somewhat similar, but I think a little bit more interesting effect, which is if you show a red disk for 20 milliseconds, even though it's only 20 milliseconds, you will perceive a red disk. But if you do the red disk for 20 milliseconds then a green disk for 20 milliseconds, you perceive a yellow disk. You do not perceive a red disk or a green disk or a red then a green disk. You perceive a yellow disk. So what happened to the red disk? And if you say, well, these are things that are on time scales of tens of milliseconds, that's not relevant for ordinary perception. And then there's these experiments, these are called Gabor patterns. I actually don't know why they're called Gabor patterns, where you have these little lines. And what they simply do is they have people guess at which direction the lines are oriented towards in this paradigm. So you see everything's sort of very faint. It's like everything is very subtle, right? You fixate, and then the target flashes, and then you're cued to one side or another, right? There's this interstimulus interval that is between minus 350 to plus 350 milliseconds. So the big interval, right? This is almost a third of a second. There is a third of a second, and then it's the fainter circle is how is the cue that you're supposed to pay attention there. And on purpose, it's fainter so it doesn't mask the cue. And then there's a delay, and then you respond. And here, whether or not you can correctly judge the orientation of the lines or guess correctly in the orientation of the lines, it depends on how the cue is. And then there's one of the most famous ones, which is the color phi effect. And I'm going to show you this website here. And see, not if you can look at my schedule, but the color phi effect here. So can people see this? Is it working through the Zoom? So the question is sort of, what do you see? Would anyone like to describe what they see?
I see a red dot blinking over the letter A and a blue dot blinking over the letter B.
Yeah. Anybody see anything else? So what you described, Lola, is exactly what is there. Oh, that's interesting. Sorry, I think I froze. My computer froze for a minute. Apologies. What you described, Lola, is exactly what's there. And the question is, if we make some of these adjustments, maybe going a little bit further apart, whether anyone sees a sense of motion of the red dot sort of moving towards the blue dot. Does anybody see a sense of motion? And it is said that this is a subtle effect, and it may be different for everyone. It may also have to do with the size of sort of the screen that you're looking at. You can adjust all these different parameters that make it sort of do different things to sort of change the speed of it in different ways. I don't know, is that looking at all like it's moving to anyone? Not really. I've got Mark. Mark thinks a little bit.
It does.
Yeah. So
It was moving for me the whole time, honestly.
yeah.
Yeah, regardless of the manipulation. So
Yeah, it was moving for me as well. I showed it to Amy. She thought that if it didn't have the A and the B there, it would be much more likely to look at that like it was moving. Interestingly enough. So this is a me just go back to the slides here. So this is a real sort of classic experiment that I think does work in most people if you get the parameters right for that. And the classic one actually has it moving not only, oh yeah, no, this is just showing distance over time, right? So that one of the things that's very interesting is in addition to the apparent motion, where you see these like little dots go across, and that is how I saw it most of the time, is that there's this color change sort of in the middle. And the thing that is mind-blowing to the people who have been working on this color-fi phenomenon and trying to understand it is that, like I said, if you get the parameters right, that people end up perceiving the blue stimulus before the blue stimulus is presented. You know, that's how it appears. So like, how does that work? And it turns out that we think the answer is actually the same. It's actually turns out it's the same answer as to why we see motion pictures as moving. And again, just sort of for fun, I actually came across this little
So I have a
thing.
plant package and yes,
Sorry, we have
it's
the
more
ad,
fruit trees. I got two more.
A motion picture is a series of pictures
Do you guys
projected
hear
onto a screen,
the?
creating the illusion of movement.
So it's sort of
By the
interesting.
1800s,
This is
humans
the
had discovered
first,
photography, projection, and
the
motion.
first
We
film.
just hadn't put them together. Then, a guy called Edward Muybridge changed everything. He set up 24 cameras linked to tripwires to take photographs of a horse galloping. He developed and later projected the images onto a screen using his invention, the zoopraxiscope. The result was 2 seconds of movie history. Here it is, the first motion picture ever made. Get your popcorn.
So it's interesting to look at this horse galloping, you know. Does it really seem like motion? You know, I think you can still sort of see the individual frames a bit. But here's another, actually an old movie that certainly had all these different frames. This one's in black and white. It was done in 1902. And they're actually rolling eggs. I think it says it on the, it's the White House lawn. It's like the Easter egg roll in the White House. And this is certainly also little frames, but in this one, it totally looks like it's real motion, you know, to me. And it's like part of our brain that we're able to sort of infer this motion from still pictures that I wanted to share with you. And then there's these other types of illusions as well. And this is a very famous one called the cutaneous rabbit. And the idea, as is illustrated here in this picture from this book that was fun to read on consciousness by Susan Blackmore. And the idea is, if you hold out your arm and you have to look the other way, and then your friend or the experimenter then taps 5 times on the wrist, 3 times at the elbow, and twice near the shoulder. And it has to be with the right amount of timing. It can't be too fast or too slow. What you find is it feels not only like 3 separate taps, but it apparently feels like an animal running up your arm. And again, when it's done in the right setting, it's apparently very reliable. And the question is, how is it that you consciously feel these different taps? And so these illusions can work in the visual domain, they can work in the tactile domain. And there's this interesting effect where you can have it actually be multimodal. And in this illusory audiovisual rabbit, you can actually have these 3 tones paired with these 2 lines that are apparently moving in space. And you see an illusory flash that seems to be, so these are flashes, I'm sorry, these are flashes, the bars are flashes. You see an illusory flash paired with the tone, and then it can sort of go the opposite way where you can have 3 flashes, but if there's only 2 tones, it is actually the middle flash is suppressed and you don't see it. So all these sorts of weird things. And then I wanted to bring in a couple interesting ERP experiments, and this, can potentially be something that might be interesting to do in the lab. And if the hypothesis that there are neurologic disorders that are disorders of consciousness, it might be interesting to study some of our patient populations with some of these setups. And so this is an experiment where you have a number presented. Then there's this variable delay. And you see this number is presented for 16 milliseconds. So it's really fast. But if that's all that's presented and there's no mask, you'll perceive the number. But there's a variable delay between 16 and 100 milliseconds. And then there's a mask for 250 milliseconds of letters around it. You may or may not consciously perceive the number, and you have to say whether it's greater or less than 5. So it's sort of a guessing task. And you also rate whether it's seen or not seen. And what I think is very interesting is that the red line is when people report that they've seen it. The blue line is when they report they have not seen it, the target. And the black line is when there's a control condition where there was a mask only and there was no number. And what's interesting is that by around 250 milliseconds, the brain could tell whether or not there was a number there and distinguish it from the mask. But the report, the conscious report of the perception, was later, right? Separating the red and the blue. But the red and blue together being separated from black happened way earlier. And, I'm just going to keep going, but people should just chime in, and interrupt anytime you want. Then this is an experiment that I thought was fascinating, where they use TMS to the occipital cortex to presumably disrupt visual processing at different time points. And to be honest, I don't remember from the paper exactly which location in the occipital cortex they were disrupting. These verniers, you can see this vernier is sort of the bottom line is off to the right. On the second vernier, the bottom line is off a little bit to the left. Okay, and so this, when these are presented, it presents sort of a sense of motion, either one way or the other way when they're repeated. And what they found in this experiment is that when you did the TMS pulse, would either make the second vernier be perceived more than the first, or later on, the first vernier was more perceived than the second. So you can actually use TMS as sort of a post addictive stimulus to disrupt perception. So again, something that might be interesting to look at experimentally. And then the next experiment is this very interesting one by Benjamin Libet, Libet, but I'm told it's pronounced Libet, not Libet, although I would think it would have the French pronunciation, but apparently it's not. And the idea, this is a very controversial experiment. Not everybody sort of thinks it's as interesting as I think it is. But it has been reproduced. It was done in, I think, the 70s and 80s. I actually have the paper in my collection if people are interested. But the idea is he had subjects wired up with EEG, and he had them look at a clock that was turning so that they could report when they had a certain decision. When they made a decision, the decision they made was when to flex their wrist. And it wasn't actually push a button, it was flex their wrist. And they had some EMG electrodes on the wrist. And that was how they knew that the wrist was flexed. So people didn't have to push a button. And there's this readiness potential of the motor cortex. And so people were instructed, whenever you have decided to flex your wrist, you note the time on a special clock. And what they found was that this readiness potential on the EEG happened before people said they were going to flex their wrist. So this was quite mind-blowing when it came out, and people still don't have a good explanation for it. I think our paper has a good explanation for it, but people didn't really understand, like, well, how could, the wrist flexion, the readiness potential go on before people decided. Kylie?
Could one explanation just for the time difference be that they also had to make like they had to note the time on the clock, which happened after they decided to lift their hand, which might explain.
Yeah. I mean, I think that's an interesting idea, that it has to do with the time of sort of the conscious perception rather than the time of the readiness potential and the decision. And I have a little video on this as well, which I think explains it perhaps somewhat better than I did. Let's see if I can get this going here. It's only 2 minutes.
Put your hand in front of you and flex your wrist. You presumably first had a thought, flex my wrist, that then caused your wrist to move. That's how it seems. But Benjamin Libet's experiments in the 1980s have cast some doubt on that. In his neuroscience lab, he wired up subjects to an EEG machine measuring brain activity via electrodes on their scalps, and then asked them to choose to perform a simple hand movement when they felt like it. He also got them to record the time at which they made a conscious decision to move their hands. Disconcertingly, he found evidence of brain activity initiating the movement hundreds of milliseconds before the conscious decision was reported. In other words, his experiments seemed to show that the conscious decision didn't cause the movement. The brain activity bringing about movement started before the individual willed anything to happen. Some people think this is proof that free will is an illusion, that our conscious decisions are more like reports on what is already happening than the causes of our action. Libet didn't go that far. He thought that we might not have free will, but there's still time for what some have called free won't, a conscious veto of an action that is started in the brain. Others are more skeptical about the implications of these experiments. They point out difficulties of recording the time of a subjective decision to move and question whether Libet's findings could apply to more complex conscious decisions based on reasons, such as the decision to reject the claim that Libet's experiments undermine our idea of free will.
So anyways, so oops, I think I need to shut that down. So there's a lot of different difficulties, and yeah, so we're going to come up to a good break point in just a minute. I'll give people we'll stop at 2:20, so people have time to get ready for their next meetings. There was another experiment that this one I actually don't have the original article, but Dan Dennett in his book Consciousness Explained described in detail. So let me describe it to you. I'm actually going to stop the slides for just a minute. So in this experiment, so this was Gray Walter was a neurosurgeon, and as is still done today and was done more at the time, the patient was undergoing a possible resection for epilepsy. And this patient had frontal epilepsy based on the EEG, which is not uncommon. And there were electrodes implanted into the frontal cortex. And, why don't we say it was on the left side, and the patient on the right side was given a slide projector control. And people probably don't even know what a slide projector is these days. But like before you had like computers and PowerPoints, if you wanted to do a slideshow, you would actually use a thing called a projector. And there were the actual little film slides, paper on the outside. Yeah, anyways, so they would push this little button to advance the slides. And he told them, it was like pictures of animals and wilderness. Like anytime you want to, look at the next picture, just push the button. And what people had the impressions of was that as they were getting ready to push the button, it seemed that the slide projector advanced. And when they actually pushed the button, they were afraid that it would advance twice in a row. And it turns out that the reason it didn't advance twice in a row is that the projector, the button was fake. And what actually advanced the slides were the electrodes wired into their motor cortex. But, what Dan Dennett talked about, and, is that this is another example like the Betz experiment where the brain is making the decision, and then we consciously make the decision afterwards. That was sort of the point of that experiment. And it's like if you believe the Levet experiment, I got to share my slides again. If you believe the Levet experiment, it sort of very well supports that idea. And then I'm just looking at the slides I have left. Yeah, so we're just about done. We're just about done. And so then there's this other interesting thing where conscious sensations are referred backwards in time. And there's this phenomenon of chronostasis. And the idea is that in chronostasis, when we look from one part of the room to another, we do what is called a saccade. And during that time, what our retina sees is a big blur of images, but people do not experience a blur. What we experience is the environment just seems normal when we look around the room. And what happens is that the percept of where our eyes land is put backwards in time to fill in the time when we should have had a blur. Okay. And so I'm going to wait till this GIF finishes, and then we'll go back to the beginning. So we have a student who's looking at their term paper and they got an A. So they're very happy. They're looking at their paper. They perceive the paper. Then they saccade to a clock. They look at a clock. Clock says 01. But what happens is this 01 fills in the time of the blur. So they actually end up with the first second is actually there for like a second and a half. It's there longer. And it turns out this chronostasis happens with auditory sensation as well. And I think I will stop right here, and we'll pick it up at the next time, because I do want to give people 10 minutes. So any questions in the last minute or comments? All right, well, I hope that this was both interesting and a little bit fun. I enjoyed talking about it with all of you. And the other thing is, this is the very first time that I've created and given this slide deck. And I always want to improve my presentations. So if there are things that you think I could do better, shoot me an email and let me know. All right. Well, thanks everybody. And I will see, I think, just Mark at 3. And so everybody else, have a wonderful 3-day weekend.
Thank you.
Bye, everybody.